All right, welcome back. So here we're talking about 5.2 critical points. So these are the locations where we kind of explored a lot with when the average rate of change involved with mean value theorem was 0. You're saying the derivative equal to 0 and kind of solving that. That's the idea, one of the ideas behind the critical points. So a critical point is a point that has the possibility, the key word there is possibility, of being an extrema location, meaning a max or a min, a local peak or a local valley. The key word there is possibility because it does not have to be a max or a min, as we'll explore in 5.3. So there's two ways to find critical points. It's set up when the derivative is equal to 0 and also where the derivative does not exist. Now, there'll be a fair number of times when the derivative does not exist. It's actually not a critical point because it's based off a vertical asymptote location or something along those lines there. But we also have to account for the fact that when you have a sharp turning point in a graph, like an absolute value function, so the derivative obviously would not exist right there, but it is a extrema location, so we do have to account for that. So that's what we have to look at when the derivative does not exist, as well as when the derivative is equal to 0. So starting off straightforward, we have f of x equals 1/3 x cubed minus 9x plus 24. So our derivative is a very simple power rule. We get 1/3 times 3, which is 1, so it's x squared minus 9, and we set equal to 0. Now, a lot of times you'll solve it as linears or sometimes quadratics. This is a nice binomial that we can isolate. So it's x squared equal to 9, square rooting both sides, we get plus or minus 3. So we have possible critical points at positive and negative 3. Whether they truly are a critical point or not will be determined once we get into the idea of what actually creates a minimum or maximum in 5.3. So that's a simple polynomial. Could also have one that's based off a radical and or rational function. So this would really be the same thing as 4 minus x squared to the negative 1/2 power. Half because of the radical, negative because it was the denominator. We take our derivative. So f prime would be a negative 1/2. 4 minus x squared to the negative 3/2 now, times a negative 2x, which gives us positive x over 4 minus x squared to the 3/2 power. So because it's a fraction, we have two spots to worry about. The numerator is set equal to 0, is going to give you when the derivative is equal to 0. So f prime is equal to 0 when x is equal to 0, but there's nothing else going on there, so just x equals 0. If that was like x plus 2 up top, we'd have x plus 2 equals 0, and we'd solve it out. We also have to consider when the derivative does not exist, which would be based off the denominator equaling 0. So 4 minus x would equal 0 when x is plus or minus 2. But unfortunately, in this case, because it was based off 1 over the square root of 4 minus x squared, if you plug 2 or negative 2 back into the original, you get a vertical asymptote. So they're technically not a true critical point. So it's only at x equals 0. So you do need to always make sure if it's coming from a does not exist answer, you always substitute back into the original and make sure you get an actual quarter point location. If you don't, then it does not truly count as a critical point because it's not really a quarter point then. All right, then we also have trig. So we have 2 sine of x over 2. So we go ahead and take our derivative. So we get 2 cosine of x over 2 times 1/2 for the derivative of the angle, which means just cosine of x over 2 equal to 0. So cosine is equal to 0 on the unit circle at least, pi over 2 and 3 pi over 2. We should include both positive and negative coterminal angles there just to make sure we have enough room here. So I'm just going to go ahead and rearrange this. So I'm going to say we've got 5 pi over 2 and 7 pi over 2 in the positive direction, negative pi over 2 and negative 3 pi over 2 in the negative direction. If it turns out when we do this that we get answers that don't have I'm not crossing off something at the beginning or at the end, I haven't fully filled out the window from negative 2 pi to 2 pi, then I'll expand out more positive or negative coterminal angles. But here we conclude, see we're going to multiply both sides by 2. So we get negative 3 pi, negative pi, positive pi, 3 pi, 5 pi, and 7 pi because all the 2's cancel. Now only one from negative 2 to 2, so negative 3 pi is out. So my lowest critical point's at negative pi, and then 3 pi and everything beyond that's also out. The highest point is at pi. And since I've canceled out both the lower and the upper range, I only have those 2. I don't have to worry about giving more from coterminal angles from the beginning. So I got negative pi to positive pi for our 2 critical points. All right, so your unit circle problems, make sure you are comfortable solving them out, getting your basic answers. Generally not going to be anything too crazy. but you do need to make sure you have your basics from the unit circle, especially sine and cosine down. You don't really see a lot of questions involving tangent or the other ones, simply because their derivatives are a bit more complicated. Still possible to be seen, but more often than not, you'll see sines and cosines. It's a simple enough derivative, but still requiring unit circle knowledge. Now, where this all is leading to, and we'll discuss again in more detail in 5.3, but the idea of increasing and decreasing intervals. A function is increasing when the slope of the function is positive. So you can see that right here from 1 until we get to like 3, we've got a positive slope. But then we got a negative slope after that, that's where the function is decreasing. And then a positive slope, and then a negative slope. So the slopes, since we talked about numerous times in the past, slope is equal to derivative. When we talk about there being a positive slope, we're talking about being a positive derivative. We talk about a negative slope, we talk about a negative derivative, which is why if the derivative is positive, that means the function will be increasing because of the positive slope. Whereas if the derivative is negative, then the function will be decreasing because of the negative slope. So we'll be able to use this concept of the value of the derivative like we did when we talked about velocity and different applied context problems in Unit 4, recognizing derivative being positive or negative meant a certain thing. We're going to apply that, but in the context of a graph. So when we talk about things increasing or decreasing, things about that when we get into 5.5, talk about the idea of concavity, things being concave up or concave down, and this is how we also talk about minimums and maximums. So if we take a look at this scenario right here, the number of fruit flies in Mr. Kelly's kitchen at time t days is modeled by r of t equals 2t cosine t squared flies. Is the number of flies increasing or decreasing at time t equals 3? So we're looking for whether something is increasing or decreasing. We're looking for the slope, which means a derivative. Now, don't automatically assume the function is you need to take the derivative of it. It depends on how the problem context is. R of t is defined as flies, so it's not a rate, so it's not a derivative. So we want to find r prime at 3, which means you need to do your derivative. Now, you can do this algebraically. This is a product rule, so 2t would be 2, and then leave the cosine t squared alone, plus leave 2t alone. Derivative of cosine t squared would be a negative 2t sine of t squared. So this would come out as 2 cosine t squared minus 4t squared sine t squared. And then you can substitute 3 into this and see what you get numerically. That's if you want to do it by hand. But again, your calculator, you have your n deriv tool, you can do that as well. Either case, you should be getting negative 16.6584, which means the number of flies is decreasing. At t equal to 3. Now, if the problem is set up slightly differently, if maybe they said the rate at which fruit flies enter his kitchen is modeled by r of t equals 2t cosine t squared flies per minute, then the whole increase and decreasing at time t equal 3 is not r prime at 3, but rather r of 3. So you do need to watch out for the wording of the questions and whether or not it's going to represent a derivative term or it's not. So just make sure you're careful with that. All right, so that's it for our critical points and getting into the idea of increasing and decreasing. We're going to talk more about increasing and decreasing with 5.3 in the context of a minimum and a maximum point. All right, so I'll see everyone next time for those videos.